First of all, what is volume? Volume is a figure is the measure of the amount of space that it encloses. So volume represents how much it will hold on the inside to fill it up, okay? So area, surface area are 2 dimensions. Even though you use multiple side lengths and all for surface area, it's actually the area, if you flatten it out, 2-dimensional. Volume is 3 dimensions. So you have your base dimensions, that's 2 dimensions, and then you have a 3rd dimension of depth because you're talking about how much it is to fill it up. So when you do units, you're actually going to do cubed. So anytime you see cubic units, they're talking about a 3-dimensional or typically volume, all right? If a prism, so the first formula that we look at is the volume of a prism. If a prism has a volume V cubic units, a height of H, and a base area of capital B, the volume is the area of the base times the height of the prism. So once again, you need all of your area formulas from all of your shapes, okay? Very simple formula. Area of the base times the height. Okay, area of the base times the height. Look at this first example. Volume of the triangular prism. So once again, with a prism, remember that your bases are your figures that are congruent and your sides are your rectangles, okay? So the base of this particular one is this right triangle here that they've given us. And then the height of this would be the distance between those 2 triangles. So the height of the prism is going to be this right here, distance between the 2 triangles. Now, in this case, they did not give us the height, the base of the triangle itself. We need to find the area of this triangle here. So in order to do that, we really need that A. So how am I going to find that? Yeah, Pythagorean theorem. So I'm going to say 8 squared plus A squared equals 17 squared. So when we do this out, we'll say 64 plus A squared equals 289. When you subtract from this, you get what? 225. And the square root there is 15. So A is going to equal 15. And now I'm just going to do area of the base times the height. What is the area of a triangle? How do I find that? 1/2 base times height. So 1/2 15 times 8, that is my base. And I'm going to multiply that by the height of my prism, which is what? 13. And when you do all of that, you get 780. You actually don't even have to round it, so I need that. 780 centimeters cubed. That is a cubic unit there. The weight of wet snow is 0.575 times the volume of snow in cubic inches divided by 144. How many pounds of wet snow would a person shovel in a rectangular driveway that's 25 feet by 10 feet after 12 inches of snow have fallen? After 12 inches of snow have fallen. So we are going to... So they wanted in inches because we're going to divide by 144 when it is cubic inches. So we want to convert these to inches. It's already 12 inches deep. That's what they've told us. So we are going to convert the 10 to inches as well as the 25 to inches. So 10 inches or 10 feet in inches is just 120. Just multiply by 12. 25 in inches would be 300. And then we already have this in inches. You definitely want to make sure, I mean, even if they didn't say we were going to convert at the end, you want to make sure that you have them all in the same. So even if you were just finding this volume, you'd have to convert one or the other. But they've already told us that they want us to divide in cubic inches, so we want to convert them all to inches at this point. All right, so we are going to first find the volume. Area of the base is a rectangle, a 10 by 25 rectangle, and inches 120 by 300. So the area of that base is going to be 120 times 300. And the height of that particular prism, they said 12 inches of snow have fallen, so we're going to multiply that by 12. This is going to give us 432,000 cubic inches, which is what they told us we're looking for. Cubic inches. To find the weight, they've given us the formula for the weight. You take 0.575 times the volume divided by 144. So we are just going to plug that in. 0.575 times the volume divided by 144. And when we do that, the weight is 1,725 pounds. That's a lot of snow. Just like we were finding surface area of prisms and cylinders, it is the same formula. It is the area of the base times the height, but the area of a circle is pi r squared. So they list the same exact formula here because it is the same. Base times height, right? But they actually broke it out for you and said the base is a circle, so it's pi r squared. But you literally just have to remember this one formula. The area of the base times the height. Whatever the figure is on the bottom, that area times the height of it. All right, and so for this one, area of the circle is going to be pi r squared. They already gave us the r. And the height they gave us at 12.4. So when you know all of that information, it's rather simple. You plug it in. You are going to have to round it with pi in there, and you're going to get just what happens when you plug it in. All right, cubic meters there. There are going to be times like B when you don't have everything you need, okay? They have given you the diameter and they have given you the diagonal, and we have to calculate the height here. So what do I do to calculate this height? Yeah, Pythagorean theorem. It's going to be 5 squared plus whatever my height squared equals my 13 squared. All right. This is a Pythagorean triple, by the way. 5, 12, 13 is always what it is when you have 5 and 13. So H is going to equal 12. So my height here is 12 inches. And now I'm just going to do exactly what I did. Pay attention when you have these. The most common mistake is people using that guy right there. We actually need the radius. So just, yeah, pay attention when you're doing these. Don't make a silly mistake. But it is going to be pi. The radius here is 2.5. And then the height is 12. And that will round to 35.6 cubic inches. All right, thing I want to talk about in this section is when you don't have a right solid. All right, they've done a good example here is these coins. When you have volume of a right cylinder or an oblique or one that's, slanted, the concept here is if two solids have the same height and the same cross-section area, at every level, then they have the same volume. And so what they've done is they've taken this stack of quarters, right, which has a certain volume, and they've just slid it to where it's not sitting straight up. The volume did not change at all. Just because it's leaning over didn't change the volume, okay? And so if you look, you do have to have the perpendicular height. So if I were doing this one, if I'm looking at height, I'm going to go straight down for this one. That's obvious. But for this one, you're still going to go straight down. All right, so when you have an oblique, you're going to use a perpendicular height. That's all they're going to tell you there. And so that's what we have with this one. The volume of this is just going to be exactly the same. We're going to say, well, it's pi r squared times my perpendicular, my altitude there, which is 452.4 cubic yards. So it's the same thing. It just don't let it throw you off. Just look for the perpendicular height. All right, so let's try some of these. Look at bottom of page 691. We're going to do 3, 4, and 5. So for the triangular prism, you have a base for the triangle of 8, height of 12, and height of the prism itself as 6, 288 cubic centimeters. For 4, you did have to calculate your height. Pythagorean theorem, you should have gotten 754 cubic inches. And for the last one, they really gave you everything you need. You just have to divide that diameter, 3,180.9 cubic millimeters.